That's the kind of maths today. We're going to do through the 2024 National 5 Maths Exam Mock Paper 2 from Mr Cruickshanks. Thank you very much for that again. For all the students out there studying, good luck in the exam and let's start. Okay, question 1. Find the equation of a line through with points 1 minus 3 and minus 2, 6. Give your answer in its simplest form. So this is equation straight line, so we need the gradient. Then we use the y minus b equals mx minus a is the way I do it. Or your school might have used y equals mx plus c. So we've got gradient is equal to, you need to know this formula, y2 minus y1 over x2 minus x1. We label one of the points x1, y1 and the other one x2 and y2. So then we just sub in 6 minus 3, watch out for double minuses, minus 2 minus 1. 6 minus 3 is 9, minus 2 minus 1 is minus 3. Simplifying that, 9 divided by 3 is 3, so it's minus 3. There's our gradient. Now we use y minus b equals mx minus a. Or you could use y equals mx plus c, but this is the most common way. And we label one of the points a and b. Any one you want, I'll just use the first one, a and b. So y minus 3, watch out for double minuses, equals minus 3 x minus 1. So that's y plus 3 minus 3x, multiplying out, a minus times a minus is a plus, so plus 3. Taking the 3 over to the other side, minus 3x. Well, it's going to be 3, and then take away 3 is 0, so it's just y equals minus 3x. And we're done there. SQA National 5 Maths 2024 Mock Exam Question 2, Paper 2. Okay, in 2022, 868 school pupils sat the first ever higher application maths exam. This is expected to increase by 85% for the next 3 years. Calculate the expected number of pupils who will do it in 2025. Give your answer to the nearest 100. So this is appreciation. So your basic steps are, it's going to increase by 85%. So 100 plus 85 equals 185%, which as a decimal, divide that by 100 is 1.85. So that means we start off with 868. We times by 1.85. And the power is 3 because it's 3 years. Using a calculator. 868 times 1.85 to the power of 3, 5495.85, 5495.85, bunch of other numbers, but we have to round to the nearest 100, so that's 5,500, and we're done there. Question 3. The carbon dioxide concentration levels in the National 5 Maths classrooms are recorded at the start of each school day. The CO2 concentration levels measured in parts per million for the 6 classrooms is shown. Find the mean and standard deviation. So start of the exam paper, standard deviation, you're given 2 formulas. I always use this one. It's the square root of the sum of x minus x bar squared all over n minus 1. And you just draw a little table. So you've got x minus x bar, which is the top of the formula, and then that squared. And x bar is the mean. So you write all your numbers first. Taking your time, don't miss anything. And then you add all them up using a calculator. Add them up using a calculator. 634, 850, 721, 983, 1037 is 4225. So we can work out our mean straight away. That's the x bar, 4225 divided by 12345. 845. Parts per million if you want to be exact, but basically I've not been taking off marks for lack of units in mean and standard deviation. Okay, so now we take away the mean from each of these numbers. 634 minus 845 is minus 211. 850 minus 845 is 5. 721 minus 845 is minus 124. 983 minus 845 is 138. And 1037 minus 845 is 192. So now we square each of the numbers. 211 squared, 44521. Okay, ignore the minus because a minus times a minus is a plus. That one's 25. That one's 15376. 138 squared is 19044. And 192 squared, 36864. And now we add all of them up. 44521 plus 25 plus 15376 plus 19044 plus 36864, 115830. 115830. So that means our standard deviation is the square root of 115830 over 4, because it's 5 numbers, so we take away 1. Square root, open brackets, 115830 divided by 4, close the brackets, is 170.169. That's about 170.2 parts per million. And we're done there. Okay, so next part of this question. The CO2 concentration levels in 5 English classrooms are also recorded. In these classrooms, the mean was 923, and the CO2 concentration levels, standard deviations 180. Make 2 valid comments. So let's look at mean first. We've got for math and English, and the maths was 845, and the English is 923. And the standard deviation, we've got maths was 170.2 or 170. And for English, we have got 180. So let's compare the mean first. On average, that's always the statement, average. And it's talking about the CO2 concentration levels. CO2 concentration levels were greater in English rooms. And that's because 923 is bigger than 845. Okay, next statement. Standard deviation is about variation. So the CO2 concentration levels were, and I always like, more varied in, and again, English classrooms. And that's because 180 is bigger than 170.2. Alternatively, you can say CO2 concentration levels were more consistent in maths classrooms because 170 is less than 180. More consistent means you pick a smaller number. So this paper seems to skip a question, so this is really the fourth question, but it says question 5, solve the equation 5x squared minus 10x plus 3 equals 0 to 1 decimal place. So that's a quadratic, but to 1 decimal place means I'm using a quadratic formula. So start of the exam paper, x equals minus b plus or minus the square root, b squared minus 4ac all over 2a. So my a is 5, my b is minus 10, my c is 3, so substituting minus minus 10 plus or minus the square root of minus 10 squared minus 4 times 5 times 3 all over 2a, which is 2 times 5. So that gives me plus 10 plus or minus the square root, and you can do that bit in your calculator. 10 squared minus 4 times 5 times 3 is 40. All over 2 5s is 10. X is 10 plus root 40 over 10. X equals 10 minus root 40 over 10. Working out them separately. 10 plus root 40 divided by 10 is 1.632. Always unrounded first. And 10 minus root 40 divided by 10 is 0.367 with a bunch of other numbers. So rounding them, 1 decimal place, 1.6, and this one is 0.4, not 0.3. And we're done there. Number 6, solve algebraic within equation 3 minus 2x plus 1 is less than 6x plus 5. Remember, it's actually a fifth question, but because of the numbering being off. So 3 minus, 2x plus 2 is less than 6x plus 5. Collecting like terms, I get 1 minus 2x less than 6x plus 5. Now I always like to keep my x's positive if I can. So I'm going to add 2x to both sides, because that's the smallest. So I get 1 is less than 8x plus 5. Taking away the 5 then, you get minus 4 is less than 8x. Divide by 8, minus 4 over 8 is less than x, or minus a half is less than x. So you can rewrite that. That's a completely fine answer for National 5. You can have the x on the other side, but if you want to write it on the correct side, you change the sign. So it's minus x is greater than minus a half, which you would get if you had kept your x's to the left, but you divide by a negative, and you need to remember to flip the sign if you divide by a negative, so just watch out for that. Question 7, but actually the 6th question. The diagram below shows a circle, and AB is the diameter, ABC is 31, and BDO is 62 as shown. Find CAD. So C to A to D. It's shaded anyway, so I just usually start by just finding as much as I possibly can. So there's a couple of rules for circles. Let me just trace this one out for you. There's no tangent because there's no line outside the circle, so no tangent meets a radius at right angles. So we're looking for isosceles triangles and right angle triangles inside the circle. So let's look for a right angle triangle to start with. If you've got a diameter, it makes a right angle triangle at the circumference. So there's a right angle there. So I can immediately do 90 minus 62. Use a calculator if you want. 7 to 82 is 28, and I can write 28 in here. I can already see as well diameter, right angle triangle, so I can see another right angle there, so I'll just note that one in. And now I'll use isosceles triangles. How do I know they're isosceles? Because if I've got a radius and a radius, then they've got two the same, so at the ends they're the same. So I can now see that since they're the same, I'll just put dashes on them. That is 28 down there. I could work out this and this and this, but I don't really need to because I'm close to the end here. I've got this right angle triangle, and the angles in a triangle are up to 180. So I can just do 90 plus 31, which is 121. 180 minus 121 is 31, 41, 51, 61, 71, 59. So I get 59 on this side. And now we've got the answer, 59 plus 28, 59, 69, 79, 89, 88, 87 degrees, and we're done there. Now, it looks like we've fixed ourselves, so this is actually the 7th question, it's number 7. A straight line has equation 2x minus 7y equals 3, find the gradient. So gradient, if it's written like this, is giving you the equation, you're looking to rearrange it into mx plus c. Don't immediately jump in and say the gradient is 2. It's not the number in front of x, only when it's y equals. So I move everything over. So I've got minus 7y equals 2x becomes minus 2x plus 3. Divide by minus 7. So I've got minus 2 over minus 7 plus 3 over minus 7. Simplifying it. Now what do I mean by that? Well, a minus divided by minus is a plus. So that's an x, sorry. That's 2/7 of x minus 3/7. The gradient is now equal to the number in front of x, which is 2/7. And we're done there. Change the subject formula to x. Now, you've got y equals 3x plus 4 all squared. You might be tempted to multiply brackets out here, but that's not going to work because you're going to get x squared. In fact, what you need to do is the opposites. So opposite of square is square root, both sides. So I get square root of y equals the square root of something is just the something, so 3x plus 4. That's a little bit tricky, that. Now take away the 4 to get 3x. Now divide by 3. Or x equals root y minus 4 all over 3, and we're done there. Question 9, the shape below is part of a circle. The height is 25, the radius is 14. Find the width. So it tells us the radius is 14. So the width, so this is a Pythagoras and a circle question because I can make a right angle triangle just by doing something like that. So setting up my right angle triangle, centre to outside is a radius, so that's 14. I don't know the width, but do I know this? Well, I do, because if I draw a dotted line here, that's 14, so 25 minus 14 is 11, so that's now 11. So I've set a right angle triangle up, so a squared plus b squared equals c squared, but c is the longest side, so I've found a shorter side on a or b, so I'm taking away. So I can say I'll just call it a squared is 14 squared minus 11 squared, so a is the square root of 14 squared minus 11 squared, which you can just do in one go. 14 squared minus 11 squared in brackets is 8.66. And now that's my width, because that's my A. Well, it's not really my width actually, because I need to double it, because I've only cut it in half. So my width is 8.66 times 2. Just double my answer on my calculator. 17.320. Get my units right. Centimetres. And you can round it if you want. 17.3 would be reasonable. And we're done there. You might get an answer of 17.4, and I'll tell you why. You might have done your square root of 14 squared minus 11 squared and got 8.66 and round that to 8.7 and then double that. So basically you've double rounded. I would have preferred to double it first, then round, but you'll be fine. Question 10. 2 cartons of milk are similar, mathematically speaking. So it says the small carton has a height of 16 as shown and a volume of 650. Let's just take a note of that, 650 millilitres. The large carton is 24 height. Find the volume of the large carton of milk. So we'll look at scale factors first, and we'll start with linear scale factor, LSF really, which is 24 over 16. Now no need to simplify because you're going to use it anyway. So I now want the volume. So to get the volume, I use the volume scale factor times the 650. Now it was 24 over 16, so I'm going into the big over small. So the volume scale factor is just the scale factor cubed times 650. Which is 2193.75 millilitres, and we're done there. Let's go in National 5 Maths 2024 Mock Exam Paper 2, question 11. Solve the equation 3 tan x plus 4 equals 2. So take away 4 to start with. Let me write that so it's clear. 2 minus 4 equals minus 2. So then divide by the 3, or write it as a fraction, minus 2/3. But it's a negative, but I still just do the inverse tan of 2/3 and use the cast diagram. So I've got 2/3 here. Get my calculator. Shift tan 2 over 3 is 33.69. Or about 33.7 if you just want to do one decimal place. So that's that, but that's not any of my x's, because if we look at the cast diagram, tan is positive A and T, so S and C, which is 180 minus and 360 minus, so x is 180 minus 33.7 or 360 minus 33.7. So we're going to get two answers. 188 minus 33.7 is 146.3 degrees, and 360 minus 33.7 is 326.3 degrees, and we're done there. Question 12. Calculate the magnitude of this vector. So magnitude is like Pythagoras, well it is actually, because you find it's the length of the line segment. So the magnitude, do it like that, is the square root, and we just square all the numbers and add them. 3 squared minus 4 squared and 5 squared. It's just a calculator job, guys. There's no reason to do it without. Square root 3 squared plus minus 4 squared plus 5 squared is 7.07. And we're done there. Now, a non-calculator question on this would maybe ask you to leave it as a simplified surd, but since it's a calculator, it doesn't mention anything, then just leaving it to a reasonable number of decimal places is fine. Question 13. Express 2x plus 18 over 5 times 1 over x plus 9 as a single fraction. So times and fraction means just times the top, times the bottom. So I've got 2x plus 18 times 1. So that just gives me 2x plus 18. And then I've got 5 times x plus 9. So 5x. 5 times 9 is 45. Now, looks like I'm done, but if you can factorise, it means you might be able to have common factors that you can then simplify by. So I simplify the top, 2 common factor gives me x plus 9. And the bottom, 5 common factor also gives me 5 times x is 5x and 5 nines is 45. And you've got the same top and bottom, so they just disappear, leaving 2/5 at the end, and we're done there. SBA National 5 Maths 2024 Mock Exam Paper 2. Question 14. The diagram shows a sector of a circle with centre angle 60. The radius is 12. AB splits the triangle ABC and the shaded segment, calculate the area of a shaded segment. So it's an area question. So I've got sector of a circle, so area of a sector, but then minus, if I did that, that would give me the whole area. So then I need to take away the area of a triangle. So let's work on that. Area of a sector you need to know. So for a sector, it is angle 60 over 360 times pi r squared, because it's an area, pi times, and it's 12 squared. And then for a triangle, you can check the start of the exam paper. A triangle is a half AB sine C. That's 0.5 times, well, 12 and 12, and the angle in between. 12 times sine 60. So let's work out these separately, and then take them away. 60 over 360 times pi times 12 squared is 75.398. And the other one, 0.5 times 12 times 12 times sine 60 is 62.353. And a bunch of other numbers. So I've got 75.398 and a bunch of numbers minus 62.353. Notice I'm not rounding, I'm just saying that that's what it was. And that gives me 13.045, and the units would be centimetres squared. And now I'll just round that to somewhere reasonable, like 13.05 centimetres squared. And we're done there. Question 15. Julian and Michael are testing out their drones together at point S. Julian, from a starting position, Julian's drone travels 25 metres on a bearing of 45 degrees. What's a bearing? It means it starts at north and goes clockwise. So I've got north clockwise, so that's 45 degrees. Michael's drone travels 80 metres on a bearing of 110. So if his is 110, that means that this whole angle is 110. So I can now find this angle just by doing 110 minus 45, which is 65. And it now says calculate the distance between the two drones. So it's this distance here. So how do I usually work this out myself? I've got 1, 2, 3 sides, including the one I'm trying to find. So it's a cosine rule. So as long as I've got the angle in between two sides, I can use the cosine rule, which I've got, so I'm ready to go. So from the start of the exam paper, it says a squared equals b squared plus c squared minus 2bc cos a. I just remember it has to be angle in between, and then it's these two sides. So that is 25 squared plus 80 squared minus 2 times 25 times 80 times cos 65. That's a squared. So what does that equal? We can just do that in one go. 25 squared plus 80 squared minus 2 times 25 times 80 times cos 65. 5334.52695, a bunch of other numbers, and then I'm going to square root that. So a equals the square root of 5334.52 blah blah blah. Square root 5334.52695 is 73.0378. Blah blah blah. Reasonable place to round, 73.04 or 73. And it is meters because it's a length. And we're done there. Don't worry too much about your rounding unless it says rounding. I mean, technically 73 would be the best there because everything was given to us in two significant figures, but I wouldn't worry too much about it. I know a lot of people would put 73.04 or something like that, so just don't worry too much about rounding. You'll be fine unless you ask to actually round. This has been Claire Maths, and today we went through the 2024 mock exam paper for Maths, National 5 Maths, Paper 2. Hopefully you found that useful and helpful. If you did, give it a like and a thumbs up. Maybe subscribe to the channel. More great content tomorrow. And take care, stay safe, goodbye and good luck.